Today, we're going to look at basic principles of early childhood education, especially applied to math curriculum. And what we are trying to do is modify the curriculum for the specific purpose of job preparation. That's right. So early childhood development, you might say, why would you be training a child for employment? Well, many of the things that they learn very early in life cannot be corrected easily later, and the things that they don't learn can't be filled in later. And so we're going to look specifically at math and the little simple things we can do along the way. We're going to do it one practice at a time in a series of videos. But before we do that, I think there is some important principles we have to cover. First of all, not all children learn at the same pace. And one of the big challenges I see across schools that I have visited in America and here in Uganda and Nicaragua for that matter, or Guatemala, the little places that I've been, is that we often hold back the highest achieving students because we're trying to teach kind of to the average. And then we also have a challenge facilitating the kids who have the biggest challenge learning because they seem to be distracting from the class. And so what I am going to suggest here is that you try to target the curriculum to each individual child, which actually isn't as difficult as it might seem. I use this analogy of creating a great football team quite regularly because people see it. You know, if you have a child on your football team that scores more goals than the other kids, and maybe he's a great defender as well, you would not say, hey, I need you to sit down for a while so that the other kids can get opportunities to score goals and the other kids can. No. The goal is to win games. And by promoting that one child and telling that one child that you have an extra responsibility, not only do we need you in the game scoring goals, you have to practice harder than all the other kids, because if you get tired, we're gonna lose. And in fact, that's the kindest thing you can do for all the kids, because one of the other challenges we have is that the other kids need something to look up to, some goal, some benchmark. And we do that so naturally on a football team. Yet when we transition to the classroom, we don't see the same opportunity. And so I'm going to suggest that the goal is primarily to identify the champions, give them extra responsibility, and move them into leadership roles so that the other children have something to look up to and something to model. And so this also ties into communication skills, because when a child becomes highly competent at a young age, they also gain the ability to teach at a young age, which is developing the communication and leadership skills. And so I'm going to start here one at a time, and we're going to go through possibilities of what can be done with these different elementary mathematical teaching techniques. And then at the end, we'll have a conclusion about what our goals and benchmarks should be by grade level. So let's get started. So let's go ahead and start with baby class. And in Uganda, baby class means like 3-year-old kids about, where my son is now. And one of the biggest misconceptions we have is that, look, these kids can learn this math so easily when they're 5. So why would we try so hard to teach them when they're 3? And that is faulty logic. What we actually have is an opportunity when these kids are young. It's just like a newborn baby. The only thing they're really capable of understanding is human emotion. And they learn through eye contact, through facial expressions, and through nurturing or even urgency. They feel and they know things. And if they're given an abundance of those opportunities when they're very, very, very young, they grow up to be more alert and more aware little children. And the same idea applies to math when they're about 3 years old, and language development too, and we'll get to that in a separate series of videos. But really putting a abundance of effort into teaching little children math pays off enormously. And so you have to believe that. A 3-year-old who gets ahead even in counting and adding and subtracting, by the time they're 5, they're going to have a better instinctual understanding of math. And you got to realize there's kind of this cutoff about how the cognitive ability of a brain around 7 years old. And kids that have an extra ability to understand the world, by the time they're 7, it's very hard to take that from them their whole lives. They'll have this advantage their whole lives. And so we need to really work hard with very little children with math. And what do we mean when we say teaching a 3-year-old math? First of all, it starts with counting with your hands. If I, as a teacher, say 3, I want all the children to put up 3 fingers. If I say 5, it's 5. And we work with one hand first. You don't need to go to 6 because, believe it or not, adding an extra hand to a 3-year-old can be quite overwhelming for them. So really working out a routine, you say 3, they get 3 fingers. You say 1, you get 1. And of course, with that, we need to be counting as well. And I highly recommend that you just use beans. They're affordable, they're easy to keep in the classroom. The kids won't eat them. You know what I'm saying? So there's not a distraction from the classroom. And kids can have enough beans. And when you say 3, they can put up 3 fingers, or you can say 3 and they can pull out 3 beans into their pile. And maybe it's helpful actually to draw a circle on the page so that the kids really understand that when you say 3, you mean 3 inside the circle. And then you can say 5 and they can put 5. And you want to get to the point where they're looking at them and not counting them. So of course, when you start, they're going to go 1, 2, 3, 4, 5. But then eventually, you can have a mess and they can say, all right, there's 5. And that's a deeper understanding that a 3-year-old is absolutely capable of, right? And then of course, as we grow, we can draw 2 circles. And we can put a plus, and we can put an equals, and we can draw a 3rd circle. See? And of course, I didn't draw those circles proportionally maybe the way that I should, but I can say 3 plus 2 equals 5. And these are just conceptual understandings. And these are just ballpark things. Please be creative. Come up with other ways of doing it. Before we move on to past this idea of very elementary counting, a more advanced finger counting method for these children is saying 2 plus 1 is equal to 3. And again, be careful. Don't go too fast. You really want this to become systematic and routine. So stick to numbers that add up to 5 or less. 2 plus 3 is 5 is fine. But don't do 4 plus 2 is then 6. That's going to be overwhelming for them at first. Of course, you want to get there eventually. And in fact, this can even turn into teamwork and group work activity. For example, if I want to say what's 6 plus 7, I can put 2 kids together in a group and have one of them make 6 fingers and have the other kid make 7 fingers, and then they can count them together. And so this is elementary, it would seem, but for a 3-year-old, this is quite ambitious. And the large majority of the children in baby class are perfectly capable of this level of math. And many of them are going to go much beyond there. And we're going to move into more advanced counting techniques. The next method of counting that we're going to look at is called tally marks. And tally marks are great for, again, conceptualizing and visualizing numbers. And believe it or not, this gets relatively sophisticated, meaning that many kids in P1 and P2 can still be using these methods and not be considered behind, all right? But the most advanced children are going to be well past this before P1. But nonetheless, let's look at it. What a tally mark is saying this is the number 1. And you know, again, the number 1, and you can even have them set a bean beside it. This is the number 2, and this is the number 2, and this is the number 2, and you kind of get the method. And then, of course, this is 3, this is 4, and then 5, I think everyone is familiar with this. The 5th line is at a diagonal. And it turns out that this type of adding can be quite helpful to children who are trying to visualize the math. Because remember, visualization is what makes competent math students, not processes, not memorization. You know, you find many kids, you say, what's 7 plus 2, and they spit out 9 really fast. But then when they even have to draw it out here, 7 plus 2 equals 9, that becomes more challenging for them, when in fact it should be the opposite. This should be the easy part, and putting it into number form should be the hard part, because if this is the easy part for them, it means that they really understand the math, and then the process of writing becomes the more difficult part. And of course, I like to put these, you know, even many children in baby class can get to the point where they understand this elementary math. By middle class, certainly, what's the last class called? It's baby, middle, and then top class, right? And certainly by top class, this is something that the large majority of the students are capable of doing with relative ease. And the point of the tally marks isn't just to give them physical meaning, but to help people conceptualize so that they move to doing it with mental math. We really want to get to the point where the kids stop counting on their fingers and stop doing things like this. And tally marks are a great transition to mental math, because they start seeing the lines more easily than they can move their fingers. And so the goal here clearly is to move to the point where simple addition is done in the mind without any writing whatsoever. Tally marks really can be developed into more significant math. For example, we might want to say, what is 12 plus 17? And what we ask students to do now is be a little more creative and say, look, there is 5 and 5. This is 10. And there is 5 and 5, and this is 10. And now here is 2 and 2. There is 4. Here is a 5. And of course, there are many, many different ways of doing this type of math with this same type of constructive process. But ultimately, they can see that 10 and 10 is 20, 5 and 9 is, or sorry, 5 and 4 is 9, and 20 and 9 is 29. And so this is the type of process that can be used to help visualize math, because kids like drawing lines, they like seeing things, and they like being creative. What we don't want to do is give them one exact way to do the problem where they end up memorizing the process instead of developing a more complete understanding of what is going on. And so that is just one other thing we can do with tally marks that is useful. Before we move on, I want to talk about subtraction at the most elementary form. And actually, the way that I've always taught subtraction to very little children is not the same way that we do addition, because addition is so easy for a child to visualize. They can see two things, and then they can see three more, and say that equals 5, and that process. But the process of taking away is actually quite more abstract. And so, for example, if you say 5 minus 2, as they say, all right, maybe I take away 2 and I get 3, as much as that makes sense to you and me, that's actually quite abstract to a 3 or a 4-year-old. So a much easier thing to do is to do it with counting objects. And so what I like to do is actually just take something like some random amount of beans and sit them down and say, how many are there? We can even do less than that to start. So now there's 4 beans on the paper. And I tell the child, now count them, and the child will count the 4 beans. And now I'm going to put my hand on top of it. Now they can't see. They know there's 4 under there. And I'm going to reach my hand in, and I'm going to take 2 out, and they can see the 2 that came out. And now I can say, how many are left under my hand? And when they say 2, and you open up the hand, it gives them a sense of reward when they get it right, because now they can count them for the first time. And this works quite well up to subtracting, let's say 10. If you put 9 under your hand and take 4 out, advanced child in this technique can now tell you there's 5 left under your hand. And that's pretty self-explanatory. But the process is a little consuming. And so one of the things that's very difficult in these very young ages is to get kids to take leadership roles. And one of the challenges that we have in our education system is that we separate the kids by age, which of course was never actually a really healthy idea. That was done largely by Henry Ford and Hitler with their discovery of the advantages of this Prussian model of making military children. And we kind of lost something in the process. And what we lost was the leadership and communication that comes from when one child teaches another. And like these very simple techniques with subtraction can be very consuming for one teacher. But yet, if you have P3, P4, P5 kids that are really excited about teaching and being part of a process, they can be pulled from their classes for little bits of time and put into the baby class and the middle class and top class and be teaching subtraction and things like this, because those kids are perfectly capable of hiding objects under their hand and making it exciting for the kids when they get the right answer. And of course, we get back into then what would happen in the upper class with the leadership students missing. Well, the students that find the subject more challenging and find discipline more challenging can get the teacher's attention at those times. And in fact, there's lots of ways that we can be quite creative about making sure that our top learners get the appropriate level of attention from the adult teachers so that they're pushed to their individual limits. And again, there's no right answer to this question. There's no curriculum. There's just the idea of we can do better, we can be creative, and we can get each of these children to learn at their individual limits. And when we adapt that philosophy from the earliest ages of the children, what we end up having is the ability to develop a leadership class within the community, which only helps everybody. It only helps everyone. Once you have children that have moved way ahead and they're able to assist in teaching and mentoring little children in their education process, the learning rate increases dramatically, the reputation of the school increases, the workload on the teachers decreases. And this is something that we can certainly do together. And so this is just one little example of hiding beans under your hand and how that little process can be quite consuming for a teacher in baby class with 8 kids trying to count beans. But as soon as you integrate a couple of real helpers in the classroom, it becomes a rewarding and less cumbersome process. Let's move on to fractions now. And I think fractions are one of the subjects, especially with small children, where there's a massive misconception. You know, I've heard people say, oh, they learn fractions in P2 or P3. I completely disagree. And again, one of the things that's very interesting about teaching math is that you're actually teaching logic and you're teaching reasoning skills and you're teaching language development all at the same time. And so fractions are one of those things that the earlier you introduce it to children, the more they're going to become comfortable with it when it's time to do math with fractions, for example. And so I think when people talk, they're going to teach fractions to children, they immediately start thinking, oh, well, I'm going to teach what 1/4 plus 1/2 is. And of course, that's a more advanced idea that's well beyond baby class or middle class. Although I do think a lot of kids in top class are perfectly capable of that level. And for those of you who aren't Ugandan, top class is like 5, 6 years old kids. There's many that are capable of math with fractions. But let's talk about fractions and how we teach them and how it teaches language and logic at the same time. My son is 3 years old. He does not know what 1/2 is now, but I'm confident that I can teach it to him in a relatively reasonable amount of time. For example, if I say, give me half of your apple, does he know what that means? Not right now, but I think he can get there. Give me half of a piece of paper. And see, I now have it in a sentence. It's not just a half. It's not just a number 3. It's now involved in a process, right? And of course, in that comes back to numbers and counting. Can you turn that paper into 2 pieces? And then I'm going to tear the paper in half. And these are things that are easy to do and demonstrate in front of the classroom. And of course, you know, one of the things that I find very interesting, you know, teaching kids to take paper and actually fold it in half using their fingernail, really fold it, and then fold it back the other way. And of course, this is a used piece of paper from teaching chemistry earlier, but fold the paper back and forth so that it makes a strict line, and then tear the paper carefully after you do that. And these are things that kids can be taught during a math class that actually helps them develop some skills with their fingers and some attention to detail. Because if I end up with 2 halves of a piece of paper and I put them together, they should be the same size. And so I took the piece of paper and tore it into 2 pieces that are the same size, which means each piece is 1/2. See that? We're working in language development and reasoning and logic. And these are things that cannot be emphasized enough if we develop it at a younger age. The younger that they start getting that type of logical understanding into their brains, the faster they're going to develop. And that's hard to take back. Remember, we have this little benchmark, and it's about 7 years old, where the cognitive ability of a human being is well formed. And it's hard to catch up after that. Not impossible. Never underestimate the ability of a highly motivated and determined and creative and ambitious person. But why not gift these children that ability now? And so let's do this together. Let's start tearing pieces of paper into pieces, and pretty soon we don't have to be too creative to imagine that we can tear the piece of paper into 4 pieces by folding each half in half again, and then have 4 pieces of paper that are all the same size, which means that each piece of paper is 1/4. See that little language process? That is something that can absolutely be integrated into students, and they can be able to repeat that process back to the teacher by the time they're in top class. And the more ambitious kids might be there by top class. And of course, there might be some kids that find it challenging that are learning this much later, and that's okay. There's nothing wrong with that. What only problem comes is when we stop encouraging the fastest learners to move forward at a very aggressive pace because there's some kids in the class that don't understand yet. They'll understand later. It's okay. Let the kids move forward. Get the kids developed at the youngest age possible, because once they get that cognitive ability at a young age, no one can ever take that from them their entire lives. And of course, once we have a conceptual understanding of what 1/2 is, we quickly have to move into a written form of fractions. And so I like to teach fractions with circles to start. And so I like to draw a circle and draw a line between the circle. And of course, it's a little time consuming on the board with chalk, but I think it's worth it to then say, hey, I'm going to kind of color in. And again, it can be a little messy after a while, but when you're first teaching the kids, it's important to try to keep your circles really concentric and keep your coloring in the lines and really let them know that that is 1/2. And so that is 1/2, and I'm going to introduce them into a numerical version of 1/2, and that is 1/2. And of course, the first thing we're going to learn is 1/2 plus 1/2. And again, I'm not going to try to fight their visualization. I'm going to work with it. So the next circle, I'm going to color in the opposite side so that they can see that piece goes with that piece. And this is another 1/2. And of course, if I was more artistic, my circles would be the same size. But it turns out I'm quite good at teaching this math to small children, and I'm not incredibly artistic. So that's not really a limiting factor. But we can now say, look, here's 1/2, and here is 1/2. And I want to add them together. And so that's going to equal, and I can draw the circle. And I can split it in half. And I can say, I'm going to put this half right here. And I can take the time to color it in first. And then I'm going to put this half right there. And then that can be one whole. And then, of course, at the same time, don't get in too much of a rush. At the same time, we can go back to these two pieces of paper that are now torn in half and say, here's 1/2 and here's 1/2. And if I put them together, it's a whole piece of paper. So 1/2 plus 1/2 is a whole piece of paper. One of the things that I really love about teaching math to very young children is you're not just teaching math. You're teaching logic, you're teaching reasoning, and you're teaching language development. And so this might seem simple, but it's a great first step. And of course, be patient. We can count by halves. 1/2, comma, 1, comma, 1.5, comma, 2, comma, 2.5, comma, 3. This is something that you can help the students visualize. You can certainly get your same pieces of paper back out, and you can get whole pieces of paper on top of that. This is a whole piece of paper, and here's a half a piece of paper. This is 1.5, and if I add one more half to it, this is now 2 pieces of paper, and then I can take the 2 pieces of paper away and are the 1 piece of paper away that is 2 halves, and I can replace it with another piece of paper. So this is now 2 pieces of paper. And then if I add a half to it, this is now 2 1/2. And if I add another half, this is now 3. Well, when I get to 3, 2 halves is the same as a whole. So now I can put that down and get this whole piece of paper back. And now I have 1, 2, 3 pieces of paper. And you get the process. And the kids can see it. And again, classroom management becomes a big factor, because one of the biggest barriers to your fastest learners moving ahead is that the kids that find it the most challenging are also the ones most likely to distract your fastest learners. And so classroom management becomes a big thing. But also I think it's appropriate to sometimes work within the classrooms to separate the kids. For example, this type of counting math is very available to your top class students, your 6 years old. This type of counting is also really appropriate for P1 and P2 kids. It's okay for those kids to get together and for us to be a little more creative about the space within our school and who occupies that space at what time. Nonetheless, this process is very available. This level of counting by halves is very available to kids much younger than you think. And so I would recommend that you really don't underestimate your children. Go ahead, get into the process, and work hard to identify the ones who are understanding and not exclude them from this learning process only because the majority of the class finds it too difficult. The world is going to be controlled by the champions. And the more of them we have within our society, the better everyone is. If we get some small fraction of the population of Lyra earning a significantly higher income, that helps everyone. And that is ultimately the goal when you say employment-based education. We're working to make sure that every single student is learning the abilities so that when they become of adult age and employable age, they are employed in the way that's most productive and helpful to society. And so it's our responsibility as teachers to make sure that every student is given the opportunity to achieve at their individual best, independent of how fast they learn. And so we will go on to look at more advanced fraction math in just a moment.